Hi, my name is Anish Tuteja. I'm a professor in material science and engineering at the University of Michigan. My group works in the area of surface coatings. So there's been a lot of different anti-fouling solutions that have been developed in the market, but a lot of them actually make use of heavy metals, which are pretty toxic to the local environment. So there's a big push to try and develop coatings and paints that are anti-fouling, but are much more environmentally friendly, hopefully not negatively impacting the environment in any way. So what we've developed are actually using anti-fouling molecules that already exist in the marine environment. There's many natural organisms like corals and sponges that also face the challenge of fouling, other things wanting to attach onto them. And to prevent those things from attaching onto them, these different creatures in the ocean secrete different chemicals to prevent the attachment of other organisms. And so what we've done is taken some of those same chemicals or molecules that exist in the nature and incorporated them into a functional paint that can be applied onto boats and ships. And this allows us to make anti-fouling paints without negatively impacting the environment. Yeah, so we believe that this will not have a negative impact in the environment and the marine environment and wherever this paint is utilized, because primarily these molecules are coming from the ocean, so they already exist in the ocean. So it's not like we're adding new chemicals or molecules to the environment. So the economic impact can be hugely significant. The marine biofouling is a huge challenge for the marine industry, for all sorts of boats and ships. The economic impact has been typically estimated to be anywhere between $30 to $50 billion a year, not just in the extra fuel that ships and boats use to overcome the drag, but also in the portion of time that the ships have to be dry docked, they have to be removed from operation, they have to be repainted before being sent out. And so there's a huge economic impact of marine fouling on the naval industry in general. Specifically for Navantia, given how large the organization is and the number of boats and ships, we believe this can be significantly impactful, both in terms of reducing the fuel usage, but also in increasing the lifetime of ships and the operation time of ships at sea. There's a number of applications, both beyond the defense industry, in the general marine environment, but also in all sorts of antimicrobial coatings that these things can be utilized, be it antimicrobial for clothing, be it antimicrobial for hospitals, be it antimicrobial for shoes. As we imagine, there's going to be a lot of civilian applications for the technology. This technology was developed in my laboratory at the University of Michigan by some of the funding that was provided by the Office of Naval Research in the US. There's been a number of people that have been involved from the initial to now where we are. A lot of initial support from, as I was saying, from the US Navy, but a lot of support now from Monodon in trying to scale this up and apply it to real world applications. Overall, I would imagine there's been at least 5 PhD students in my group that have worked on this, and many more that are working on it now.